Welcome to this presentation in Intro to Engineering Design, and today we are talking about the empirical rule as a part of our statistical analysis. We've learned a little bit about this as we've worked through our recent discussions on accuracy and precision. So as we start further digging into the empirical rule, a couple notes you'll want to consider. The first one, that this applies to what we call normal distributions. That means it has to look like the bell curve. If it is not a normal distribution, this will not work as well. So almost all the data needs to fall within 3 standard deviations of the mean. The empirical rule says that if the data are normally distributed, 68% of the observations fall within 1 standard deviation of the mean. 95% will fall within 2 standard deviations of the mean, and 99.7% of the observations will fall within 3 standard deviations of the mean. All right, let's take a further look into what that means for us. So if we take a data set, much like we have here, we have our data here, and we've plotted that with a dot plot first and then made a bell curve in a histogram. I guess not histogram, but we've kind of plotted to show the bell curve of that, which means it is normally distributed. We've calculated a mean of 0.08, and we indicate that by the blue line right in the center. We've also calculated a standard deviation for our sample data. All right, taking that a little bit further, we've got our chart all set up. We can see the normal distribution in the bell curve. We mark our mean as 0.08, and 1 standard deviation to the right means we're going to take our mean, add this up. We add those two numbers, in other words, our mean plus 1.77, which is our standard deviation, gives us 1.88. We go the other way as well, because if you think back to a previous slide, 68% of our data is going to fall within 1 standard deviation either way, plus or minus from the mean. So in this case, 0.8 minus the 1.77 gives us 1.69. So we're saying with a 68% confidence level that our data will fall between these two numbers. That will be true 68% of the time if we've got that normal distribution. We can then take it a step further and say that with 95% confidence of the time, we can say that our data is going to fall within 2 standard deviations of the mean. So in other words, we'll take our standard deviation, the 1.77 times 2, which is 3.54. We've added that to the mean, and then we've also subtracted that from the mean. So 2 of the standard deviations plus 2 standard deviations minus, which means we have a range that 95% of our data will fall within 2 standard deviations below or above the mean. We can basically state that 95% confidence level. All right, let's take some data and look at it. Let's think about the fling machine that we just got done making. And we had a question that kind of related to this. And when you answered that, you probably didn't quite know how to understand or explain that. This will help you with that next step. So assume that you've repeated the launch of the cotton balls with your device, and you use the mean and the sample deviation for your data. We want to predict the range of the travel distances within 68% that your basically, where will 68% of those cotton ball tests fall? And what we would then do is take a step further and say, okay, if we launch that thing 100 times, 95 of them would fall within 2 standard deviations. All right, here's what that looks like. So assume that your statistical analysis resulted in the following. You had a mean of 2.35 feet. You had a sample standard deviation of 0.76 feet. So then, with those two numbers, we can say that 68% of the cotton ball launches would fall within 1 standard deviation. 1 standard deviation of the mean. So if our mean is 2.35, we subtract it from that, taking the lower limit. We add it adding the upper limit, which basically means, and I'll get my picture out of the way a little bit here, with a 68% confidence level, we can be assured that 68% of those cotton ball launches should land between 1.59 feet and 3.26 feet. And all we're saying is take our mean, add one standard deviation to it, and subtract one standard deviation to it, and we can say that 68% of them will fall within that range. If we want to go one step further, let's assume that our statistical analysis resulted in the following. So the same thing, we have a mean of 2.35 feet. We have a standard deviation of 0.76 feet. So we predict that the range of travel within 95% of the cotton balls, they would fall plus or minus 2 standard deviations. In other words, we take our mean, subtract the standard deviation times 2, gives us our lower limit of 0.83. And the upper limit, we would say our mean plus 2 standard deviations, so 2 times 0.76 gives us the upper limit. So then we can say, as our prediction, 95% of our cotton ball launch tests will land between 0.83 and 3.87. Okay, so that's how the empirical rule works for us. We can look at the mean and we add standard deviations and subtract. 68% of our data falls within one standard deviation. 95% lands within 2 standard deviations. And we'll apply that to some statistical analysis that we'll be doing going forward. So that's the basics of the empirical rule. Thanks for watching.